Hello, good day viewers, you're welcome to Chemistry Hangout. I want to especially greet us from anywhere you are watching me from. If you are just watching this YouTube channel for the very first time, I want you to click on the subscribe button and turn on the notification bell so that when I upload any video, you are going to be notified. If you're already part of the Chemistry Hangout family, I want to especially welcome you to another teaching on this very particular channel. If you remember the last video I uploaded, we are doing a series of how to name inorganic compounds. I have posted some videos. If you have not watched that, kindly watch that very particular video. But very quickly today, I want to do something, and I want to believe it will help a whole lot of people on this channel. The Neco GC students just wrote their chemistry alternative to practical 2 days ago. Yeah, as at the time I'm shooting this video, they wrote that very particular exam. That's for 2023 Neco GC, the alternative to practical. They wrote it 2 days ago, and I still know that there are some people that have registered for GC, that's Waec GC, coordinated by Waec, and they will be writing theirs in few weeks time. Some of the students that wrote this Neco GC sent the question to me, and I want to quickly talk about the question, then solve it, so that it will give the Waec GC students, to give them this confidence to actually bring with confidence for the exam that is forthcoming. And if you are writing Waec 2 2024, if you are writing Waec 2024 Waec, this will also help you, because it will open your eyes to a whole lot of things, and it will build your confidence too. And for my co-educators, my colleagues in the field of science, chemistry teachers that are preparing students too for this exam, this very particular question too will help us to be able to prepare them well. So I'm going to be showing you the question, and I'm going to be solving it so that you will understand how you're supposed to solve it should you have that kind of question on the day of your exam. And very, very important, if you go to the first video, I already dropped 2 videos for GC students here. I already dropped 2 videos. In that video, I was explaining the difference between alternative to practical and the real practical. And I said that, on my channel, I've said that even in the video, that the alternative to practical is much easier. Yes, the alternative to practical is much easier than the real practical, because they have saved you the rigors of carrying out the practical, getting those values yourself. And that's why I dropped 2 videos. I dropped one where you have all the parameters given in the question, and I dropped another one where you have a table, you trying to fill the table and trying to get some of the parameters yourself. If you have not watched it, go and see that very particular video. But we are still going to see the 2023 Neco GC question. That's what I want to do now. So you see the question they gave them, and how they can twist that question. But if you have been watching a whole lot of my videos here, all these questions, you should know what to do. So very quickly, let's dive into what I have for us for today. So this is the Neco GC question for 2023. They did 2 days ago. I want to see the question, and let's see how we know how the question is going to be answered, so that it will give a lot of students confidence for the forthcoming exam. So the question said, A is a solution of dibasic acid H2X. B is a solution containing 1.0 gram of sodium hydroxide in 250 centimeter cube of solution. Okay, 25.00 centimeter cube of B requires 25.50 centimeter cube of A for complete neutralization of B. Now, the first question, give a reason for the addition of indicator to the base before the titration begins. Can you see that question? And if you have checked my video, if you have seen some of my videos where I did the real practical, before I start titrating, what do? I will add some drops of indicator into my base. The base will be contained in the conical flask. So when I add the base, what happens? The color of the base will change. The reason why the color of the base will change is because I've added indicator, and I need to add that. Why? So that when the neutralization point reached, I will know. How will I know? Because if I did not add my indicator, you understand? Your solution A, which is the acid, is colorless. Your solution B, which is the base, is colorless. So if I begin to carry out the titration, a colorless solution and a colorless solution, if it changes, if the neutralization point reaches, I will not be aware, and I will not even know when they neutralize. So what happens when I add the base is for me to be able to detect the endpoint, which is always by a change of color. So I need to add the indicator to change the color of the base, so that when the color changes when I'm titrating, I will know neutralization point has actually reached. I want to believe that's clear. So the answer to that question, let's solve that. The answer to that question is what? To detect the endpoint, of the titration, which is usually by a color change. I hope that is clear. So I will add my indicator to determine the endpoint of the titration, which is usually by a color change. So when I've added the indicator, it will change the color of the solution in the conical flat. So when I start titrating and I see a change of color, then I will know my endpoint has reached. Why am I able to detect it? Because the color has changed, because it has changed from the color of when I added the indicator, either mentee, orange, or flutafli, to another color when I begin to titrate. So I want to believe that is very, very clear. So another one, they said, what is the use of white tie during the titration? Of course, I've not used that on my channel, because I have been doing titration as it has been for a while. So I can actually do a perfect titration to a large extent. So me, I don't always use white tie. But of course, in the normal standard condition, there should be a white tie. And what is the work of the white tie? So that you can easily observe any color change. So when the color changes, you can observe faster, because if you do not observe the color change faster, you will still be running the acid into the conical flat, and the end point would have passed, so you will not get an accurate readings. I want to believe that is clear. So when you put a white tie, you can easily detect any color change, and that's why our white tie is always put at the base. You put your conical flax on it, or you swell it, and your white ties will act as the base. So when there is a color change, you will be notified. So you will easily see it. So the question is, what is the use of white tie? It is used to easily detect any color change. I want to believe this is clear. So when there is a color change because of the white tie, the white tie will reflect the color. You understand that? It will reflect the color that there is a color change already, so you can stop your burette and take it. So that is that. So these are simple questions. If you have been following my channel, you would have seen all this. But you might not have seen this, but I want to believe we must have had that before. Or even in our various schools, we must have used white ties to actually do a titration. But if you have not seen that before, or you have not had that before, you are hearing it now. You are always using white ties to actually easily detect any color change during titration. Okay, the third one, this one is even a bonus question. Is that which of the solution is contained in the burette? So which of the solution you have in the burette, is it the acid or the base? Then we should know from titrations that have been carried out on this channel that it is the what? It is the acid that will be the burette. But please, this is a question that you must follow it up. They said, which of the solution is contained in the burette? That's the question. So I go back to that question. They did not mention the solution for us. So they said, which of the solution? So I will just say 3. Which of the solution? Is this solution A or B? And from here they said A is a solution of a dibasic acid, and I've said that it is the acid that will be in the burette. So I can quickly answer that question. Which of the solution is contained in the burette? Solution A. That's it. Solution A will be contained in the burette because that's the acid. Okay. Then the next one. State 2 precautions that should be taken to ensure accurate burette readings. So, if you want to take your readings of the burette, you want to have a correct readings from the burette, or even your overall readings, you want it to be very, very correct. Of course, there are some precautions. In fact, for every practical, there is always precautions. For every practical, there is always precautions. Either even for physics, for chemistry, for biology, in the world of science, there must be a precaution. You are actually aiming at to get an accurate result. There must be a precaution you need to observe to get an accurate result. So what are the precautions? Number one, we have a lot of precautions for titration, but they said we should state only 2. So we can read from our books too, but I will state just 2. The first one, always remove the funnel on the burette before titration begins. You know, when you want to actually pour the acid in the burette, you use a funnel to actually pour the acid in the burette. So before you start titrating, you must remove that funnel, because if you do not remove it, you know, small drops of the acid will still be coming into the burette, and as you are titrating, it will be stylishly refilling it. I want to believe that is clear, so you have to remove that. Number 2, very important. Number 2, wash the burette with the solution it is to hold. You know, the normal thing, before you start doing your titration, your teacher must have washed those apparatus for you, okay? But before you start the titration, you don't wash the burette with water. If you wash the burette with water and you start titrating, there will still be some drops of water in the burette, and it will tend to dilute the concentration of the acid that has been poured in the burette. Do you understand that? So what we do is we actually wash the burette. Yes, we wash the burette with the solution it is to hold. And what is the solution it is to hold? It is the acid. So we wash the burette with acid first, then we can now begin our titration. We have a lot of precautions like that. We avoid air bubbles both in the burette and in our pipette. We actually avoid air bubbles. There are a lot of practical. And for your conical flask, you don't wash your conical flask with the solution it is to hold. I want to believe you know that, because if you wash your conical flask with the solution it is to hold, you know that is supposed to hold the base. So when you now pipette the base, because you have washed the conical flask with base and you now pour it away, there will still be some drops, do you get that, of base in that your conical flask. So when you now introduce maybe 25 centimeter cube or 20 into the conical flask, it will now be more than the volume you are supposed to use. So you don't wash your conical flask with the solution is to hold. So we have a lot of precautions like that, but they asked us to just list 2. So I've listed 2, and that's solved that very particular question. Okay, so that's 4. Now, these are just, you can see all the questions they asked here, they are just normal titration questions that students should be familiar with. If you have carried out titration in your school, all these things are what you should be familiar with. So, and that's the reason why I said alternative to practical is much more easier than the carrying out the practical. So from here now, I say calculate 1. Concentration of B in mole per dm cube. So we are going to B now. The concentration of B in mole per dm cube. Okay, now let's start our calculation now. What's our B? They said B is a solution containing 1.0 gram of sodium hydroxide in 250 centimeter cube of solution. In fact, if you have been watching this channel, if you are Chemistry Hangout family and you have been watching this channel, you see I have predicted questions like this over and over and over again. So, and for emphasis sake, I'm still going to emphasize on these things so that when you see it in exams, you will not find it difficult. So calculate concentration of B. So we are calculating concentration of B in mole per dm. Now, what is the parameters for B they gave us? They gave us 1.0 gram in 250. And I've said that severally on this channel, that 250 centimeter cube is not the standard measurement in chemistry laboratories. If you want to prepare reagents, most times we prepare in 1 dm cube, which is 1000 centimeter cube, except they state otherwise. But the standard measurement is 1 dm cube. I want to believe that's clear. But now in their question, they said B is 1.00 gram in what? In 250 centimeter cube. Can you see? This is what they gave us. So what do? We need to convert it now to 1000, 1 dm cube. and 1 dm cube is 1000 centimeter cube. So I can have 1000 centimeter cube is equal to x. Can you see that now? So from here, we're going to have x equals to 1 times 1000 over 250. So this is not difficult. If you use your calculator, your 1000 divided 250, that's easier. You should be having x will be what? 4 grams per day. Can you see now? So I have converted. So instead of this 1.00 gram in 250, I have converted to what? 4 grams per DMP. So it is now 4 grams. If I have written 4 grams, you are correct. If I have written 4 grams per DMP, you are equally correct. And that's solved the problem. So they now said, the question is now concentration of B mole per DMP. I have not calculated concentration of B mole per DMP. What I got is gram per DMP because I'm trying to convert from 250 to what? To 1000 centimeter cube, which is 1 DMP. So how do I get that now? Then I will use my formula, the normal mole per DMP formula. I've told you all these things will be given the normal, all this will be given in the question. All this will be given. All these ones will be given, their normal things that will be given, the atomic masses will be given. So if you are giving this, now I will now check. They mentioned sodium hydroxide in the question. Can you see? And can we get the molar mass of sodium hydroxide? We can get it because they gave us sodium, they gave us this, they gave us that. So which means this formula will solve that first question. Mole is equal to mass over molar mass. Can you see that? Why did I choose to use this very particular formula? Why? I choose to use this particular formula because my mass, my concentration of mass is already gotten. My molar mass, I can get it from here. So I will get my answer in mole per DMP. And if you are doing an exam, don't just bring any value from anywhere. Calculate those values, let them see where you got it from. Because there are marks that are allotted for that. So from here, I'll first of all calculate molar mass of NaOH, molar mass of NaOH. So this will be 23, that's what they have been given, plus 16 plus 1. So this is going to give us 40 grams per mole. I want to believe this is clear. So this will give us 40 grams per mole. So from there now, permit me to rub off this. So I will not rub off this, I'll just rub off this question. For people that do call me for questions, please, when I saw anything on the channel and you want to get the question, you can pause the video, write down the question, because most of these questions, immediately I come to the channel to solve them, most of them I even forget them. Even sometimes if I want to get that question, I need to come back to the channel myself to check it. So please, you can write this question down, write all these questions and then you follow the service because of the situation of the body. You can see it's not that big. So just permit me to rub off this. We have done this. So let me rub this off. We have solved this. Okay? So we have solved this. Okay, so the molar mass now, we have gotten that. So from here, we are still on our B1. So it becomes our mole now. It now become what? 4 grams per dm cube. That is our mass, concentration in mass, over our mole. That is 40 grams per mole. You can see this one is even easier. Because even without calculator, you can actually get these answers. But if you know you are not good in calculation, please always use your calculator. It's not a crime you using your calculator in the exam, please. If you know you are not, even if you are good in calculation, still use your calculator to confirm, because all this mistake can cost you dearly. So use your calculator. But from this, I can have 0.1 from here. You have 0.1 mole per dm. Can you see? So question 1 is sorted already. Calculate concentration of B in mole per dm. That is sorted already. Now let's go to the second one now. They said concentration of A in mole per dm. Same question. Can I use this formula? There is no need for you to rush yourself. Just look at what you have been given, look at what is obtainable, and you can tell which formula to use. So I'll look at this. I'm still using the same formula, but let's see if the formula will work. For mole, they ask us to calculate mole. Mass, did they give us the mass of this acid? No. They didn't give us the mass. Can we calculate the molar mass? No, because H2S, we don't even know what X is. Can you see? So can I use this formula? No, I cannot use this formula. Yes, I cannot use it. Why? Why can't I use this formula? The mass is not there. The molar mass cannot be calculated. So in cases like that, when I cannot use those formulas, then I'll come to my titration formula, which is CAVA over CBVB equals to NA over NB. Can you see that? Now look at something. They need something here, and that's why I like this question. They need something here. Somebody will now ask me, sir, why are you using this formula? Because our NA and our NB, we need to get the mole ratio. And the mole ratio is always gotten from the equation of reaction, sir. Sir, they did not give us the equation of reaction. How did I get my NA and my NB? What they are trying to tell you is you should write the equation of reaction because they are giving you the acid and they are giving you the base. So you are going to provide them with the equation of reaction because they know without the equation of reaction you cannot solve this. Can you see? So there will be mark for equation of reaction because if you have gotten the equation of reaction wrong, you are going to get this value wrong, and the whole of this thing you have solved will be wrong. Do you see that? So they already gave us dibasic acid. They've given us the formula here. Can you see? The chemical formula is giving sodium hydroxide. They expect you. That's why they did not give you the chemical formula. And if you have been following my channel, you see this is one of the uses of how to name inorganic compounds that we have been doing on the channel. Yes, this is how to name all these things. Because I gave us, if you remember the last video, if they are giving you the name, how to write the chemical formula, and if they are giving you the chemical formula, how to name, these things are interwoven and we need to understand them. So before I now continue with this formula, I will now write the equation of reaction. So let me erase this a bit so that the equation of reaction can come in here. So the equation of reaction now. So what is the acid? H2X is a basic acid, okay? And what is the base? Sodium hydroxide. Do you remember? If you remember, let's do that small test we did. Sodium hydroxide, sodium Na used to have plus. Can you see that? Hydroxide, they are giving you that is OH, used to have minus. When they react together, what they give us? NaOH. Can you see the uses of all these things we are doing on the channel? So that will be aqueous. Now, how do we write the product? The normal way, this one is plus, this one is minus. This will definitely be plus, this will definitely be minus. So plus we attract minus, minus we attract plus. I'm just trying to give us chemistry background. If this one dissociates, look at this on the channel, the last video. If I have H2X, what is the meaning of this? The meaning of this is that hydrogen doesn't have two valences, it has one. That's why this one is not carrying any number. So if this one dissociates, it's going to give me, can you see that? Why did hydrogen have these two? It means it is this X that has these two. When they interchange, that's 2 minus. Can you see? So I don't want to balance this now. How many hydrogen do you have there? 2. Then you can now balance. Can you see? Do you see this now? So this plus now, here, will react with this minus. This plus will react with this minus. And that will give us our product. So this is plus, will react with this minus. Can you see? So we have Na2X. Somebody will say, sir, where did you see this 2? It is because this sodium is reacting with this X. It is this X that has this 2. So if we collect it back, when it's actually making a reaction. Please, we need to understand all this. Plus, then we have this now reacting with this, then we have H2O. And even from our basic chemistry knowledge, we should know when an acid reacts with a base. They've already told us that basic acid. When an acid reacts with a base, it will always give a salt and water. That's another thing we should know. And what type of reaction is it? It's a neutralization reaction. So let's balance the equation. Very important now. Let's balance. How many sodium here? 2. You can see they are testing your overall knowledge. So we have 2 sodium here. Let's see if the equation is balanced. We have 2 hydrogen here plus another 2 hydrogen, making what? 4. But how many hydrogen do we have here? 2. So we can balance these 2. Let me put my plus here. 2 here. So let's see if it is balanced now. 4 hydrogen, that is balanced. 1x, right? 1x, that is balanced. What again? 2 sodium, that is balanced. How many oxygen? 1 oxygen. Oh, sorry, 2 oxygen here. Then how many oxygen here? 2. You can see, if I've gotten this wrong, then you will fail this question. I want to believe this is clear. You will fail this question if I'm getting this wrong. So I can have this. If you don't know the state, you can leave there, no problem. You just reduce an insignificant mark. If you don't know the state, you can just leave there, but this is the equation of reaction. So from there now, you can now slot in this one. Don't forget we are now calculating concentration of A in mole per dmP. So what is A? That's what we are calculating. Ca times what is VA? Our VA, volume of acid. They are already giving us. B requires 25.50. It's already in the question. So you know, ideally you are supposed to carry out your titration to get the average volume of acid used. But then it's in the question. Let's write it easier. So we can just have 25.50. Okay, then we have over CB. We have gotten our CB here. That's 0.1 times volume of base. That's the volume of the pipette. You've already told them. They said 25.0 centimeter cube of B is in the question. 25.00 centimeter cube of B. If you are writing an exam, don't assume that B is always 25. Can be 20, can be 25. Don't be carried away. Check the question. So for this question, it is 25. So we can now have 25 equals to number of moles of acid. How many moles of the acid we have? The basic acid, that is 1. Because nothing is here. So it is 1 moles of this 1 over number of moles of the base. 2. Can you see? So if this equation is wrong, this thing will be wrong and you will not actually get it. So from here, let's cross multiply. So if we cross multiply, let me erase this 2. We have done this 2. So from there, we make CA the subject. Then we are going to have 0.1 times 25 times 1 over 25.50 times 2. Can we see that now? So from here, our CA. Permit me to use, I don't have my calculator here, let me use my phone. I can't actually calculate that offhand. So let me use my phone. So that, okay, so for this one, we have 0.1 times 25. Just to be sure. Okay, this will give us 2.5. This will give us 2.5 over, then this will give us 25.50 times 2. That will give us 51. Can we see that now? That will give us 51. So we can now divide 2.5 divide 51. So that's giving us 0.0490. Let me leave it 0.0049 goes to 3 significant figures. So you can have 0.0049 and say 0. Let's just leave it like that. Mole per dmP. I want to believe this is clear. 0.0049. So very important. Let's be sure. Divide, let's be very sure, 2.5 divide 51. So you can see that that's 0.049. So if you want to write 0.049, it's fine. So let me leave this one, but still the same thing. Well, I love it like this because the rule is to actually 3 decimal place. So 3 decimal places is fine. More per dmP. So if you punch your calculator, you are going to get this. If you still want to put your 0, fine, you are still okay. So that is that. Concentration of A in more per dmP is sorted. You can see we have sorted this. That's equation 2. We have sorted this. Equation 2. So the next question is now saying molar mass. Please, I want us to take note of this question. Permit me to still rub up this. I will not rub up this because it's part of the question. But I will rub this one. Rub up this one. Rub up these ones. I want to believe if you want to get that answer, you can just. So, molar mass of the acid H2S, given that 100 centimeter cube of the solution A contains acid. Please take note of this place. Very tricky. Very, very tricky. Molar mass of the acid H2X, given that 100 centimeter cube of the solution A contains 0.485 gram of the acid. So this is what we need. 100 centimeter cube of the solution A contains this. So we can have the third one now. 100 centimeter cube. 100 centimeter cube of the solution A contains what? 0.485 gram. And don't forget, what did they ask us to calculate? The molar mass. Can you see that? Now, did I just say that the standard measurement in the laboratory is what? Is 1 dm cube, which is 1000 centimeter cube. So I need to convert all these two. So how do I convert? I come here to say, if 100 centimeter cube has this, then 1000 centimeter cube we have x. Can you see that now? So from here we cross multiply. We're going to have x equals 1000 times 0.485 over what? 100. So let's engage our calculator again. 1000 times 0.485. Okay? 1000 by 0.485 divide 100. And that's giving us 4.85. Can you see that? 4.85. So we have 4.85. You know, if we are getting our answer in gram, what have we calculated? Mass. But they don't ask us to calculate mass, they ask us to calculate our molar mass. So how do we go about our molar mass? How do we go about that? How do we go about our molar mass? You can see all these things are what I've done on the channel, but you just need to keep practicing them. Now, how do we get our molar mass? Look at this. Let's come back to this formula. That's the first formula. Anytime they are asked in titration, come to this formula. If this formula cannot solve it, then we can now think of other ones. So we want to calculate our molar mass. The first question is, do I have my mass? Yes, I have gotten my mass. Good. Do I have my mole? Yes, I have gotten my mole. Where's my mole? This is my mole. Can you see that? So we can now make molar mass the subject of formula here. Then we can now get our molar mass. Very simple. So our molar mass, we make molar mass the subject of formula, is going to be mass over mole. So we have mass over mole. Are we together now? So our molar mass is going to be, what's our mass now? We are getting that 4.85 gram over, what is our mole? We are getting that 0.049. Okay, mole. This is mole per dm cube. Definitely, this will be gram per dm cube. You know why it's per dm cube? Because 1000 centimeter cube is 1 dm cube. So our molar mass from here, let's see what our molar mass is going to look like. So our molar mass, let's engage our calculator too. 4.85 divide 0.049. You can see that 98.97, or let's say 98.98 approximately. Let's say 98.98. So I'm going to have 98.98 gram per mole. Please, very important. Molar mass, gram per mole. And that solves, can you see that? That solves that very question. And that's just it. So it's a bit tricky, but just understand, and you're going to find it very, very easy. Then the last question now. The last question. Now look at this last question. pH of the solution. pH of solution A. That's the amount of hydrogen ion. pH of solution A. Of course, I'm going to do a video. I think I'll talk about this topic. Very interesting topic in chemistry. Let's talk about the pH. You know, the pH meter is one of the instruments we can use to determine the acidity or the basicity of a substance. And our pH, from 1, according to what we are taught in our basic chemistry, from 1 to around some point before 7, it is acidic because your 7 is actually neutral. While from 8 to your 14 is basic. So how do we get the pH? There's a formula, there are 4 formulas we used to give them. I'll do a video on that. I'll do a series on that too. Yes, I'll do a series on pH. They gave us 4 formulas. I'll talk about that later. For pH, you have -1 hydrogen. I don't know if I've seen it, but don't worry, I'll do a video. I'm just explaining. For pOH, you have -1 hydrogen. You have H plus OH minus equals to L raised to -14. Then you have pH plus POH. You equals to 14. These four formulas are important. Don't worry, we're still going to do a series on that. So now, we want to get the pH of solution A. What is solution A? Solution A is acid. That's why I'm using pH. If it is base, if you have asked me the pH of solution B, I would have used this because it's a base. Do you see that? But since this is an acid, don't worry, I will take my time to explain this. Or I will take my time to explain this paper. So don't get yourself confused. So just take the first one. Okay, so pH of solution A. Now, the first thing I need to do for solution A is to write the dissociation reaction. This is solution A, H2X. Can you see that now? So if we dissociate, what is it going to give us? I've already even done that here. You can see, I have even done that. I don't know they will ask that question. I've done that here. So that will be 2H plus, then we have X2 minus. So, and we have gotten the concentration of hydrogen in here. Let's go back to the question. Concentration of hydrogen in here, can you see it? 0.049. Can you see that? It's 0.049. So if the concentration is 0.049, how many moles of hydrogen in here do we have here? 2. Do you see that now? 2. So which means we're going to have 2 times 0.049. Let's see what that will give us. Let's use our calculator again. 2 times 0.049. That's giving us 0.09. 0.098. So for easy calculation, what would that give us? For easy calculation, since we are, it's going to give us 0.10 approximately. Do you agree? Yes. If you approximate this, it's going to give us 0.1, 0.10 or 0.1 anyway. So from there now, we can now engage our formula. So let's engage the formula and get that solved. So from there, we are going to have our pH is equal to, because that's the question, pH of solution A minus log hydrogen ion concentration. Can you see that? So from here, our pH will now be minus log. What is the hydrogen ion concentration now? 0.1. If let's take for example the acid HCl, would have used this value directly because this will give us H plus Cl minus. We have 1 hydrogen ion. So the reason why I'm multiplying it by 2 is because we have 2 moles of hydrogen ion. So don't assume that when you are calculating pH, you always be multiplying by 2. No, it depends on the acid that you are giving. So from here, our hydrogen ion concentration is now going to be 0.1. So take your calculator, punch this. Minus log is 0.1. Minus log is 0.1. Minus log 0.1. Can you see the value given? 1. Can you see that? 1. So the pH here is 1. And on our pH, when the pH is 1, what is that? It's acidic. So that is the pH. The pH is 1. And that solves the question. That solves the question for the Neco 2023 GC alternative to practical. This is the question. So if you're a student, if you have done this, then you are perfectly correct. So for people that are doing Waec GC, you have to still take this as a guide. I'm not saying this is the same thing you will see, but from this you can pick 1 or 2 lessons that will help you on the day of the exam. Meaning for people writing GC, Waec GC, I expect you to do wonderfully well, because now it will now make it 3 videos I have dropped for you. I've dropped 2 before, and I'm solving this for you to see it and pick 1 or 2 lessons for me, so that you can actually, use that to build your confidence. And that's why I've always said, please don't come to this channel alone when you are writing exams. I've said that at your lecture time, during your lecture time, come to this channel, check the videos, even when you are not writing exam, so that it will build you. Because I tell you, even when you get to the university or you get to the tertiary institution, in your 100 level days, you are still going to do all those things. If you have an elder brother, if you have people that have, that are graduates already, you can ask them. All this basic knowledge will still be needed in your 100 level. And the more you are able to get this now, the better for you. Yes, the more you're able to get this now, the better for you, because you might not be afford with a lot of opportunity for somebody to begin to do it like this. You are now in tertiary institution and we believe you are mature. So the approach to teaching you will actually change, and that's the truth. So you can use all this to fortify yourself. You can use all this to build yourself, so that when you get there, you already know some of these things, and it will scale you through to be able to build a very good GP, like your CGPA. Okay, sorry, I'm speaking in tertiary institution language. Okay, it will be helping you to do well in the higher institution. So all these things are very, very important. Come to the channel, check previous videos. I have a lot of videos on the channel, and that's why most times on this channel we believe so much in practical, because that's an affirmation to the theories we have read in books. That's an attestation that science is really practical, and all those theories we have read in the book is actually true. So please take your time to actually go through all this. Now, if you have done the Neco GC practical and you are a bit sad because you didn't feel like this, you still have your theory and objective. Yes, you still have, if you have not done so well in this practical, you still have your theory and your objective. You can still do well there, and if you do well there, you are still going to come out with an excellent result. So this is Chemistry Hangout. We love you. We are going to finish the series of our naming organic compound students. I just have to give it a break and quickly do this to help the students that will be doing their exam in a few days. So if you are just watching this YouTube channel for the very first time, I've said that before and I'll say that again. We love you. This is Chemistry Hangout. Do well to subscribe to this channel. You are free to share this video, comment, like. For people that this video will be beneficial to them, you can share them. You might be saving a life, because some people are finding this thing difficult. So you can save somebody by sharing it with the person. You can send it to your colleagues that we need it. You have a younger brother that is science oriented. You don't need to even get to SS3 before you begin to do all these things. If you're in SS1, you're in SS2, you can begin to learn these things now, because the earlier the better. So you can send it to them. My number is on the screen too. If you are not seeing it now, go and check previous videos. My numbers are there, so you can actually chat with me if you have any issue as regards the chemistry practical. And I believe you should not have issue. This very particular explanation is clear. And for teachers that have been reaching out to me on how to prepare laboratory reagent, there is a video, a value-packed video we have done. The video has been out for some months now, and a whole lot of teachers have gotten access to it. If you are a teacher, you're still finding it difficult, or you are a chemistry educator, still finding it difficult to actually prepare laboratory reagents, you are finding practicals a bit difficult. Of course, if you are finding a practical difficult as a teacher, that's not a problem. We live to learn every day. Yeah. And we become outdated the day we stop learning. Yes, we become outdated the day we stop learning. So if you believe you have an issue with practical, you are still finding it difficult, we need that video. You can private chat me, it is available. Terms and conditions apply. You just private chat me. I will tell you what you need to do to get the video. Together we can make the world a better place. Together we can learn. Together we can grow. Till we will be having another teaching episode on this channel, I want to chemically say I love you. I want to believe you love this channel. So till we meet again on this channel, stay chemically active. Bye bye.